Hi students, Mrs. Guyman again. This is our Unit 3 review video and this is part 2. So it's going over 3.06, 3.07, 3.08, and 3.09. So this is the last half of Unit 3. Okay, so I've put together all of the formulas we've learned in this unit. Hopefully this one slide, this one page will be helpful to you. I would suggest taking a screenshot, a snip, whatever it is. Keep track of these formulas. Maybe you want to pause right now and write them all down on a note card or a sticky note. Okay, the ones we're going to focus on for this part of the video is your volume of cylinders, volume of cones, volume of spheres, and then we're going to do some ratios of volumes with similar solids. So these things right here with the stars next to them, or those star looking. Okay, so first of all, volume of cylinders. Let's go ahead and start there. 3.06 was all about volume of cylinders. And let me remind you about a cylinder. So a cylinder is like a soup can. And I can attempt to draw one here. Let's see if I can get a 3D cylinder for you. Okay, so something kind of like this. This is a cylinder, so like a soup can, a jar if it goes all the way up and doesn't like kind of come in at the bottle part. There's lots of different objects that are cylinders. Anyhow, that is what this one is talking about. So we're finding the volume. So that's the amount of space that goes inside of this cylinder shape. All right, here is our formula. We are still dealing with volume. So we still are dealing with the idea that we have big B times H. But in this case, the base right here, okay, is a circle. And so this that I'm trying to color in, and I'm not being too successful, that part right up there is a circle. And so since it's a circle, that is where we get this pi r squared. That's the area formula for the base, so for a circle. And so you can see that we take pi r squared and times it by the height. Okay, so over here in my example, let's go ahead and do this one. It says a cylinder has a diameter of 10 centimeters and a height of 20 centimeters. Okay, so remember this keyword diameter is all the way across the circle. For our formula, we need to know what radius is. So that's our first step, is to find radius. If I have the diameter, radius is half of the diameter, so I'm going to take that 10 and I'm going to cut it in half or divide it by 2. So in this problem, radius equals 5. Now, if it said that the radius of it was 10 centimeters or whatever, you wouldn't need to cut it in half because you have radius already. All right, so now plug it into our formula. Volume equals, I'm going to do it two ways. I'm going to first just use pi, because sometimes the question is going to ask you to leave it in terms of pi, and sometimes the question is going to ask you to give an approximation using 3.14 in place of pi. So let me show you what both look like. Okay, and then the height is up here. It says in the problem it's 20. So if I continue on with this, I'm still going to square the 5. So that's 5 squared is 25. And then if I carry the stuff down, I have pi times 20 times 25. So it looks like I can continue to multiply. So I'm going to multiply 20 and 25. And I'm going to get my calculator out for that. 20 times 25, oh, I know what that is. It's 500 because 2 times 25 is 50, and then add a 0 to the back. So this would be 500 pi. And that would be the answer if you could see that the answers needed to be in terms of pi, or it literally said answer with the terms of pi. So that would be the answer. We would actually put the units cubed, but because most of the questions you have, it doesn't ask for the units. They give you the units already there. We focus more or less on this part. Okay, but understand it is units, oh, not squared, cubed. It's units cubed because it's volume. Okay, the other way I told you to express this was using 3.14. So over here I'm going to go ahead and do 3.14 times 5 squared times 20. Okay, so basically it's the same information, but when we get down here to the bottom, I'm going to multiply by 3.14 instead of just putting pi. So I take 500 and I times it by 3.14 and I get 1570. So these are the same answer. One is just in terms of pi and the other one is an approximation, not in terms of pi, using 3.14. Okay, next one. So now let's move on and talk about the volume of cones. So this was 3.07, and cones look something like this shape you see right here. I think of an upside down ice cream cone, or you see the orange cones like in the road, or maybe if you play a sport you see the orange cones. So those are cone shaped. Basically they have a circular base and they meet at a point at the top. So here's our formula for a cone. Okay, right here we can see, first of all, I want to bring to your attention that we're seeing this 1/3 again. We saw this when we dealt with pyramids, right? And we were finding, so remember how the pyramids came to a point? So that's the same idea. We're still dealing with a third, or if you want to look at it like this, it's really pi r squared, because guys, the formula is not any different than a pyramid, except for the base will always be a circle on a cone. And so that's how it's different. That's why it's pi r squared instead of just big B. And then it's divided by 3. So I like to probably use this one more, but I want you to understand that either one will work. But I'm probably going to go ahead and use the one in green. They are the same thing. One's just dividing by 3 in the end instead of timesing by a third. Okay, so the things I need radius and I need height. When I look at this question over here on the left-handed side, I'm going to go ahead and start plugging in my information. And I'm going to still do it as pi and as 3.14, so I'll show you both ways. Okay, so we're going to go ahead and put pi. I can see that this 3 is representing my r because that is halfway across the base, the bottom circle, okay? And so they've already given me my radius. All I have to do is plug it in and do 3, oh sorry, I like to put this in parentheses, squared. That is a 3, not an 8 or something crazy. 3 squared times, okay, now the height is the height of the cone. So if you can see right here how this goes straight up and down, this 4 actually equals the height. Don't get confused with the 5. It's more information than you actually need. Okay, so we times it by 4, and then we divide the whole thing by 3. All right, so continuing on here, let me rewrite this using pi or 3.14 as well, so you can see that. So 3.14 times 3 squared times 4, and then divided by 3. Okay, so here we go, continuing on. So when I square 3, I get 9, so that becomes 9 times 4 times pi, and then it's still divided by 3. And so then when I combine the 9 and the 4, 9 times 4 is 36, so I get 36, and I'm going to leave the pi there for just a second, divided by 3. And when I do that, 36 goes into 3 12 times, and so this equals 12 pi. Now, I know that pi over here in this one is representing 3.14, so it's going to be the same answer, except for it's going to be 12 times 3.14. So I'm going to go ahead and do 12 times, maybe, 3.14, and I get 37.68. So we could have the answer 37.68. And I just didn't say, well, how do I know which one to answer with? So they're going to tell you, okay? Either they're going to say using pi, and it's going to be multiple choice, and you're going to see that this answer is there. Or they're going to say an approximation, and you'll see something close to this. Okay, that's cones. So let's talk about spheres. Now, spheres are unique. Spheres are their own thing, just like circles are their own thing. Okay, so you're going to notice that this formula is a little bit different. In particular, you can see that we have a 4/3 pi r. Now, that's kind of hard to see, but that's cubed. So another way to look at this, since we've shown multiple ways on these, you can look at it as 4 times pi times radius cubed divided by 3. That's just the other way to look at it, as division rather than multiplication. Oh, and I wrote 4, but I meant to write 3. Okay. So just note that that little number, it's really small. It's actually a 3. It's a cubed. Okay, so now I have 2 examples here. Here's my question 1, and here's question 2, if that wasn't clear enough for you. So question 1 gives me this sphere. Now, a sphere is a ball, okay? It's like a basketball, a volleyball, a soccer ball, okay? It's this ball right here. And if we look at this, all we really need from the formula is the radius, and then we can plug it in. So to find the radius, well, over here it shows that all the way across this circle is 9. So remember how I said if it's all the way across, we have to use divided by 2 to get the radius? Because you have to use the radius. So half of 9 is 4.5. So we're going to go ahead and say radius is 4.5 in this top problem. Now, when I plug this in, I do 4 times pi times 4.5 squared. Oh, not squared, cubed, I mean. That one can be tricky. And then divided by 3. Okay, so this is where a calculator becomes extremely handy. So I would open up Desmos if you don't have a hand calculator. Desmos.com is great for this. I would start with a 4.5 and I would cube that. So this part right here equals 91.125. 91.125. Okay, that's the 4.5 cubed. And then I'm going to times it by 4 first. So times 4. Oh boy. Times by 4. And that's 364.5. So before I actually multiply by pi, I'm going to go ahead and divide that by 3. And so I get 121.5 pi. Okay, or you could have went, excuse me, you could have went 4/3 times that 4.5 cubed, that 91.125, and that would have been the same answer. And sometimes they might give it to you as a fraction instead of a decimal like this, and you're like, well, I don't know what to do. Okay, so at this point, if you have multiple choice, I would say, okay, use my multiple choice idea and say, can I just see which one is equal to this? Like divide your fractions out and see which one's equal. You know that it has to be, or you can look at it like this, 121 and a half, because 0.5 is a half, and then do all around the world to get it to a mixed number. Or you can leave it as 4/3 times the 4.5 cubed. Anyways, I don't think they're going to ask you to do that, but just use like the knowledge you have of decimals and fractions to get there if you need to. All right, if I used 3.14 in place of pi, then my approximate answer for that would be 121.5 times 3.14. Did I say 1.5? I'm sorry. I think it maybe had just said that. Okay, so times 3.14. And we get 381.51. Okay, so those are the answers. One is with pi and one is 3.14. Okay, so now looking at the second problem down there, this time it's different because it says the volume of a sphere is 32 divided by 3 pi inches cubed. Okay, so guess what? They already give us volume on this one, and we're trying to find the diameter. So this can be a little bit tricky, and I showed you this one because there's one like this on the test. And I want to make sure that everyone has the opportunity to learn this. Okay, so I'm going to start with 32 over 3 pi, and that actually equals the stuff that's up here on the right-handed side of the equal sign. And let me change my color so you can see that. Okay, so it equals, and we can use the 4/3 pi r cubed. Okay, so our goal is to try and get r by itself. If I can isolate this r right here, then I can actually find diameter, because remember, 2 radii equal 1 diameter. So if I can get what r equals, then I essentially have diameter. So my goal, excuse me, is to get rid of 4/3 pi. Okay, but this is what becomes tricky. The opposite of timesing by 4/3 pi is to actually divide. So we still have to use solving equations that we've used forever now. I don't think we'll ever get past this solving equations lesson because we always use it. Okay, and I'm going to write that over here on this side, this 4/3, because what you do to one side you have to do to the other. And so over here on this side, it kind of like cancels out, or it becomes 1. So I'm left with r cubed on this side of the equal sign. And that equals, and then on the left-handed side of the equal sign, okay, watch what happens. If I have pi divided by pi, it becomes 1, or it cancels out, okay? Then I have 32/3 divided by 4/3. Well, I'm going to show you without a calculator because I can't show you on my calculator very well while I'm recording this. Whenever you divide fractions, you actually multiply by the reciprocal. And the reciprocal is meaning the second fraction flipped. And so instead of writing divide 4/3, I'm going to write times 3/4. Okay, at this point, you can multiply however you'd like. Multiply straight across and then simplify. I like to simplify if I can before I multiply, so I'm not multiplying big numbers. When I say simplify, I say like cross cancel. So 3 can go into itself 1 time. Okay, there's where I get the 1s. 4 can go into itself 1 time, and it can go into 32 8 times. And so that's how I get the 8 and the 1. Now, if I multiply straight across, I get 8 times 1 to be 8, and 1 times 1 to be 1. And so this whole thing that looks so crazy right here is equal to 8, which is 8 over 1, same thing. All right, now, tricky part, that's cubed. So to get rid of the cubed, I have to do the cubed root, okay? And so when I do the cubed root, this is what r equals. What I do to one side, I have to do to the other, so the cubed root of 8. Now, just like the squared root, this is saying what number times itself 3 times now will give me 8. And there's only one of these numbers that works. So if I think about it, it has to be a small number because you're multiplying it by itself. So obviously 1's not going to work because 1 times 1 and times 1 is just 1. But if I do 2, 2 times 2 is 4, times 2 is 8. So the cubed root of 8 is 2. That means radius equals 2. Now, we did all of that and still don't have our answer. I know, right? We need to find diameter. So I take that 2 and I times it by 2 more. And that equals 4. And so my answer is diameter equals 4. Okay, and that's the answer. We would answer with 4 in this question. All right, a little bit tricky. Let's move on to volumes and ratios. So when I look at these problems, and I have, once again, I have 2 problems here. And this is the last slide, by the way, so stick with me for just a few more minutes. Number 1 up here, the volumes of 2 similar solids are 20 centimeters cubed and 1,280 centimeters cubed. Okay, so first thing to note, we're given the volumes. okay? We're trying to find the ratio of the corresponding sides, large to small. Okay, so even though they start with the small one on this side, we need to start with the large one. When I say ratio, I automatically think of fractions. Okay, so I'm going to do 1208 over 20 and write it as a fraction. Now, what does this reduce to? Well, get out your calculator. Sorry, my computer was slipping. Do 1280 divided by 20, and we get 64. Now, you might think that that's the answer, because, you know, that sounds pretty good, but that's actually not, okay? That is the ratio of the volumes, okay? But we want to know corresponding sides. So, because volume is cubed, we have to do the opposite and take the cube root. Just like we did with the last problem, what number times itself is going to give us 64. If you're struggling with that, okay, and you don't know how to enter this in your calculator, try typing in 64 and then to the 1/3 power, because that will equal the same thing, okay? Anyhow, this is actually 4. So what that tells me is that the ratio of the sides have to be 4. That's your answer. Okay, so now going down to number 2, look at what's different. Now we have the side lengths, okay, and we're trying to find the ratio of the volume. So now we're going to kind of go the other direction, so opposite of what we just did. I want to know small to large this time, so I'm going to take the small one, which is 35, and I'm going to write it over 42. And then that's not going to reduce very well. I guess, let's see, 7 probably goes into both of them. So 5, 6, right? 34. Yeah, it's 5, 6. Had to double check myself, make sure. Okay, so then from here, remember how up here we took the, so right here we took the cube root? Well, this time we're going to cube it instead of taking the cube root, because we want to know the ratio of the volume, okay? And so now, you know this to be 5, 6 times 5, 6 times 5, 6, or you could just cube this one and cube this one. And I think it's probably going to be a multiple choice one, but 5 cubed is equal to 125. And 6 cubed is equal to, sorry, I don't have those memorized, is equal to 216. And those should be in simplest form. And that would be our answer, because that is the ratio of the volume. Okay, if you have any questions, please let your teacher know. Thanks for watching with me. See you later.